Hey y'all, it's Sarah. I'm back with another inverse functions video. Today we're going to be talking about inverse trig functions and their derivatives. So we're going to start out with sine and arcsine. So basically we can write it out either this way as arcsine or with the negative first power like this, but either way we pronounce it as arcsine. Or you can say inverse sine. But basically I've graphed sine here, right? And we know from the last video that basically in order to be able to invert a function, it has to be 1-to-1, which means that no two x values can map to the same y value. Now, one way that we can test for this is it's similar to the vertical line test. It's called the horizontal line test. So if I were to take a horizontal line and move it down here, we see if we're ever touching multiple places at once. And with the sine graph, we're touching multiple places at once. So what we're actually going to be able to do is restrict the domain of sine so that we can invert it. So the way we're going to restrict it is restrict it between negative pi over 2 and pi over 2. And so now if I draw a horizontal line and I move it down, just over the dark blue part, we're never touching the line more than 2 places at the same time. So basically, when we actually invert the graph, what we're essentially doing is just flipping it over the line y equals x, all right? We flip it over that line, and so here, that gives us a graph that looks something like this. And so this is the graph of arcsine of x. All right, let's talk about some properties. So basically, here's just the definition of the fact that this is the inverse. Note that we have to also mention the restriction when we're defining this. The domain of the function, the domain of arcsine is the same as the range of sine, which is going to be -1 to 1. And then the range is what we restricted, right? From negative pi over 2 to pi over 2. Now we have some properties here. Basically, arcsine of sine of x is going to equal x for x in the range of arcsine. And then sine of arcsine of x is going to equal x for x in the domain of arcsine, which is also the range of sine. All right, now let's move on to cosine and arccosine. So I've graphed cosine here, and again, cosine does not pass the horizontal line test. It's not 1-to-1, so we need to restrict it. So we restrict its domain so that its inverse has a restricted range. So I'm going to restrict it like that, from 0 to pi. And now when I flip that over our line y equals x, what we're going to get is a function that looks like this. And so that is going to be arccosine. All right. So the domain here is going to be the same as the range of cosine. It's from -1 to 1. And then the range is going to be our restriction, right? So from 0 to pi. And again, arccosine of cosine is x for x in the range of arccosine. And then cosine of arccosine is x for x in the domain of arccosine, which is the range of cosine. All right, now moving on to tangent. So basically with this one, in order to make this 1-to-1, the restriction that we're going to choose is going to be from negative pi over 2 to pi over 2. And so when we graph this, what we're going to get is something that looks like this. So this is arctangent. All right. So the domain is going to be all real numbers, all right, because the range of tangent is all real numbers. And then the range of arctangent is going to be our restriction here. So it's not inclusive, but it's between negative pi over 2 and pi over 2. So notice with sine, we had negative pi over 2 to pi over 2 inclusive as our range. Here, it's not inclusive of the endpoints. So arctangent of x equals x for x in the range. And then tangent of arctangent of x is x for x in the domain, which is all real numbers. So for all x, that's going to be true. Now notice that we have horizontal asymptotes in arctangent. And so we can write the limit as x approaches infinity of arctangent of x is going to be equal to this asymptote here, which is pi over 2, that horizontal asymptote. And then the limit as x approaches negative infinity of arctangent of x is going to be negative pi over 2 because we're approaching this asymptote here. All right, now we're going to move on to cosecant. So these are the cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent. So here, cosecant is 1 over sine. Keep in mind, there's a big difference between a reciprocal and an inverse, okay? So cosecant and arcsine are not the same thing. So basically, in order to draw out the graph of cosecant, first I've just drawn out the graph of sine, and then I've just drawn asymptotes at the zeros of sine. And so what we're going to do, it's 1 over sine. Basically, we just flip everything around. So this is the graph of cosecant. Now, notice again, this is not 1-to-1. It's not injective. We need to come up with some restriction in order to make this work. And so the restriction we're going to use is from negative pi over 2 to 0, and then from 0 to pi over 2. And so when we graph this, it's going to look like this. Wait, it's a little more curved there, yeah. So this is going to be the graph of arccosecant of x. All right, now let's move on to some properties. So its domain is going to be from negative infinity to negative 1, and then from 1 to infinity. And then its range is going to be from negative pi over 2, right, this is our restriction, negative pi over 2 to 0, and then from 0 to pi over 2. Arccosecant of x is x for x in the range, so that's going to be for x greater than or equal to negative pi over 2 and less than 0, or greater than 0 and less than or equal to pi over 2. And then cosecant of arccosecant, those cancel out. For x in the domain. So that's for x less than or equal to negative 1 or x greater than or equal to 1. Now we're going to move on to secant and arcsecant. So again, I've drawn out the graph of cosine on the left-hand side here in this dotted line, and I've drawn asymptotes, vertical asymptotes where the zeros are. And again, this is just 1 over cosine. We flip everything around. So this is going to be our graph of secant. Now, in order to make this invertible, it has to be 1-to-1 or injective. And so we need a restriction on the domain, which will become the range of arcsecant. So the restriction that we are going to choose is going to be between 0 and pi. So we're choosing this and then this. And so when we graph that, we're going to end up with something that looks like this. So this is pretty similar to arccosecant, which makes sense because, sine and cosine are the same graph, just shifted over. And so same with cosecant and secant, they're the same graph shifted over. And then with arccosecant and arcsecant, we just choose a different restriction. So here are our rules. The domain is going to be from -infinity to -1, and then from 1 to infinity. Our range is going to be from 0 to pi over 2, and then from pi over 2 to infinity. Arcsecant and secant cancel out in that direction for x in the range. And then they cancel out the other way. Secant cancels out arcsecant for x in the domain. So x less than or equal to -1 or x greater than or equal to 1. All right, and finally we have cotangent and arccotangent. So cotangent is just 1 over tangent. So again, what I've done is I've drawn the graph of tangent and drawn vertical asymptotes at its zeros. And so what we're going to do is flip everything around. Oops, that was the eraser. So this is going to be the graph of cotangent of x. And we use that to construct our graph of arccotangent. So the domain restriction that we're going to choose here is going to be from 0 to pi, because this line passes our horizontal line test. And so that is going to look like this. So this is going to be arccotangent of x. All right, moving on to some properties. The domain is going to be all real numbers because that's the range of tangent. Our range is going to be based off of the domain restriction we did to cotangent. And so that is going to be from 0 to pi. Arccotangent cancels out cotangent for x in the range, so x between 0 and pi. And then cotangent cancels out arccotangent for x in the domain, so that's all real numbers. And then finally, we have our derivatives of all of our inverse trig functions. So the first one, arcsin, it's going to be 1 over the square root of 1 minus x squared. And notice that with our trig functions, we have that pattern of like the certain ones being similar and the signs alternating. We have a similar pattern here, just different derivatives. So arccosine, its derivative is just the negative version of what we had for arcsine. And then arctangent, we're going to have something a little different. It's 1 over 1 plus x squared. And then for arccosecant, this one's going to be negative because we alternate. 1 over x times the square root of x squared minus 1. And then for arcsecant, we're going to have the positive version of the same thing. And then for arccotangent, it's going to be the same as arctangent, just negative. And those are our derivatives. All right, if you enjoyed this video, please like and subscribe, and I'll see y'all next time.